Everyone, this is Pierrick from P2 Design. In this video we will learn how to rig this little character right here. Let's get started. This character was provided by Gary Jackson, one of my students, and he asked me if I would be able to rig this kind of character to match the Lego style. This is an intermediate level tutorial. If you're a pure beginner, I don't advise you to take this class, and if you want to learn the basics of rigging and very advanced technique, I advise you to take my course, The Art of Effective Rigging in Blender. Let's have a quick overview of the rig features. There will be a head controller to rotate the head that we can lock so that the head stays in place whenever we are setting this controller, and the head will follow the target. There is a very simple torso controller that will allow us to rotate the torso and the hips separately. The arm have a simple IK and FK switch. When using inverse kinematic, you can choose whether the arm is bending or not, and whether it's following the torso or it's free inward space. You will also find a forward and inverse kinematic switch on the leg. As for the arms, when using inverse kinematic, you will be able to lock the knee rotation. We will also build a roll foot mechanism that we will be able to lock. Finally, we will create a picker that will allow us to choose and animate the different facial shape of the character. Open the Lego base and let's get started. Press Shift C to make sure that the 3D cursor is centered in the scene, and let's add an armature. Let's call it Armature Lego, and we will switch its viewport display to be in wireframe and in front. We will also display the names of the bone and their axis. The first thing I want to do is to align the first bone with the world space, so I will snap its tail to the 3D cursor, and then I will press G and Y to move it on the Y axis. I will call it root. From there we will create the deformation armature, so it's gonna be pretty straightforward. I will duplicate the bone, then I will align it with the hips, the brown part of the character, and then I will extrude another bone vertically to make the chest, and finally another one to make the head. Make sure that you properly align the joint with the separation of the different material or different part of the character. I always use the prefix DEF for my deformation bone so that it's easy to identify them. Always name your bone along the way or it's gonna be a mess. To create the leg bone, I will enter edit mode onto the mesh and try to find a few points that are crossing the center of the leg pivot. I will select one of the face that is crossing more or less the center of the leg and press Shift S cursor to select it. From there, get back onto the armature, edit mode, Shift A, this will create a new bone where the 3D cursor was set. Offset the bone more or less in the middle of the leg, and I will move the tail to the foot of the character. I will then move the tip of the bone up so that it's aligned with the base of the ankle. Note that along the way I've edited the mesh to make your life easier and make my life easier. So this is why I will switch to the arm right now and get back to the leg later on. I will be using exactly the same method as before. I will first enter edit mode on the object, then I will isolate the arm by pressing L to select all the linked vertices of the arm and press Shift H to hide. Then I will select a loop that defines the middle of the arm joint and I will snap the cursor to it. This is going to be our starting point to add a new bone. Once our 3D cursor is placed, we can go back into the armature in edit mode, press Shift A to add a new bone, then select the tip of the bone and move it toward the elbow, extrude a new bone toward the wrist, and a last bone aligned with the end. To make sure the hand bone is aligned with the forearm bone, I will select the hand bone, then the forearm and press Ctrl Alt A. This will align the bone. Then I will play a bit with the roll of the bone to make sure that the elbow rotation is aligned with the elbow joint. To do so in edit mode, press Ctrl R to be able to rotate the bone on its local Y axis. I will also tweak the position of the different joint snapping onto the geometry whenever it's needed. To get a good result, try to align the bone joint with the geometry loops. From there we can get back onto the leg, go into edit mode, right click on the leg bone and subdivide it. As usual, to properly place the bone joint, I will get back into edit mode on the geometry, select the loop that cross the knee, snap the cursor, and there, instead of snapping the bone that is offset with the 3D cursor, I will use the 3D cursor as a pivot point. Press S to scale on the Z-axis by 0. This will align the joint with the 3D cursor. Then simply extrude a bone forward to create the foot. Note that I've named all the bone on the left side using the .L suffix. This way Blender can identify those bones as being on the left side. So make sure that all the bones for the leg and the arm have the .L suffix. When you've done so, you can select all the leg bone and the arm bone, right click and press Symmetrize. From there, back in object mode, we can select first our character, then the armature, press Ctrl P and use with empty groups. We will create the groups by hand. If you now select your mesh and go into the vertex data panel, you will see that Blender has created a vertex group per deformation bones. None of the vertices are assigned to those vertex groups, so I will use the L key to select linked vertices, and with full influence I will assign them to the different bones. It's pretty straightforward. When it comes to the legs and the arm, just select the different loops and stop right over the last joint of the bone and assign them with full influence. When I've assigned some vertices to a group, I generally hide them pressing Ctrl H so that I clearly see what I'm doing. Then I will select the next loop and press Ctrl plus to increase the selection. In the next minute, I will just create the different vertex group in a time lapse. I see you in the next part. Now that the weighting is done, I will go into edit mode, parent both leg to the hips bone and parent both arm to the torso bone. I will also unconnect the ends by selecting them, pressing Alt-P disconnect. This way they will still be parented, but we will be able to rotate and move them. Since most of the bone will be rotating only on one or two axes, we can set all of them into Euler rotation, but the arm bones that we will keep in quaternion. While the Euler rotation order can be important, in our case we will just keep it in the XYZ pattern. Don't forget to set the hips, torso and head to Euler rotation too. Only keep the upper arms bone in quaternion in the whole rig. As you may know, whenever I'm rigging, I'm always using the Bone Layer Manager add-on by my friend Finn, so you can find the link in the description. Just download the latest zip version, go to Edit, Preferences, Add-on, Install, just double-click the zipped file, and then activate the add-on. Whenever you are working on the armature, you will find the Bone Layer tab on the right, and you can name the different layers. So let's call the first one def, like deformation. Before going on, we should center the whole spine. So I will snap the 3D cursor to this very centered vertex, and then I will select all the bone of the spine, switch to 3D cursor pivot, and scale on the y-axis by 0. This way the head, the torso, and the hips will rotate properly. We can also translate the neck joint connection right on the top of the shoulders. I generally don't directly work on the deformation armature because whenever I make a mistake, if I move or if I delete one of the deformation bones, this is going to be a problem to fix later on. So I will select all the bone but the root bone, press Shift D to duplicate them. We can batch rename all of those bones by pressing Ctrl F2, select bones in the data type, find deformation and replace it by TGT for target. Then I will repeat Ctrl F2, press .001 and remove it, keeping the replace slot empty. Pressing the M key, we will move those onto the second layer and we can see them appearing in the bone layer management whenever the hide empty option is enabled. Now I will constrain the deformation bone with the target bone using a copy transform. So you first select the target bone, then shift click to select the deformation bone, press Ctrl Shift C, copy transform. To see which bone is selected, you can see the name of the bone on the top left of the screen. Then it's just a matter of pattern clicking, let's say. The copy transform constraint will override any transformation, so whenever you will move a target bone, the constrained deformation bone will follow. We will start building our controller rig with the arm. We don't need to work on both arms as we will symmetrize the rig. First, in edit mode, I will duplicate the target chain with Shift D and then press X to slide it on the X-axis by 0.5 unit just to offset it for readability. I will batch rename everything searching for TGT and replace it by Ctrl FK for forward kinematic. I will also clean the .001 suffix and then I will reduplicate this chain and offset it on the x-axis by 0.5. We will use this second chain for the inverse kinematic. In pose mode, I will select the forward kinematic chain and add a copy transform constraint on each bone. The upper arm will constrain the upper arm, the forearm, etc. And I will mask the constraint so that both bones are not one on top of each other. I will repeat the process with the second chain, adding a copy transform constraint on top of the target arm. This is the base of the forward kinematic and inverse kinematic arm switch. I will now select the wrist joint in edit mode of the last chain and extrude a bone on the y-axis. I want to align it with the world space. So in edit mode, I will press Shift N to recalculate its role and select Global Z. We need to unparent this bone by pressing Alt P clear parent, and we can rename it as it is going to be our control inverse kinematic of the arm. Then in edit mode, I will select the very last bone of the chain and I will parent it to this controller. Then I will select my control first and the forearm, then press Ctrl Shift C and add an inverse kinematic constraint. Since we are constraining two bones in the chain, in the panel we will select 2 in the chain length. Now our base inverse kinematic mechanism is set. When you select the forearm bone and go into the bone option, you will find an inverse kinematic tab. This allows us to access further options, like locking the rotation on some axis. Since an elbow can rotate only on one axis, just check out which axis is the right for you. In our case, it's the x-axis. I will rename the bone. The end bone will allow us to rotate the end properly, since the Lego has a one-axis rotation. The IK will allow us to move the arm and position the end in space, and the 2 other bones will be MCH bone or mechanism bones. Before we get more complex with the inverse kinematic, we will create the switch between the forward kinematic chain and the inverse kinematic chain. We need a property bone, a bone that will hold the property of the switch. So I will simply extrude a bone and unparent it, move it on top of the shoulder. Its position doesn't matter, just think of it as a UI component. And for the sake of clarity, I will rename the second copy transform constraint of the target bone with the IKFK switch name, so that we know that we have to play on this constraint to switch. With the property bone selected, go into the bone option in pose mode, and in the custom property panel, add a new custom property. Go to edit, give it a relevant name, and press OK. Then right click on the value and copy the data path. This is kind of the address of the switch. Select one of the target bone, go to the constraint, right click on the influence and add a driver. Set it to average value, single property, select the armature and paste the data path by pressing Ctrl V. You can then click the update dependency to make sure that Blender updates the driver. Then right click and copy the driver, go on the next bone and just paste the driver. Do the same for the end bone. Now we need to unhide both constraints on every bone, and then when we will play with the property bone value or influence, it will switch the influence of the copy transform from the inverse kinematic, switching between the forward kinematic and inverse kinematic chain. To make it a simple switch, I will use Entingers in the value of the custom property. Now, to control the bendiness of the elbow whenever we are using the inverse kinematic, we will need to be able to lock the distance between the wrist and the shoulder. In edit mode, we can extrude a new bone from the root of the MCH arm IK. This is going to be our mechanism length bone. Beware, here I've made a typo and add a mu sign just after the L. Just remove it. Then we will snap the tip of the bone onto the wrist. Now in pose mode, I will use my inverse kinematic controller to constrain this newly created bone using a damped track constraint and then a stretch through constraint. Note that the damped track constraint here is not mandatory, it's just an habit. Now when I pull the controller, it will either stretch or squash the bone, following the distance between the shoulder and the wrist. We will use this bone to drive the inverse kinematic. So in edit mode, I will extrude a new bone on the y-axis from the stretch bone. This will be our MCHIK end bone, and then in pose mode I will go back into the inverse kinematic constraint and I will use this bone instead of the control end L. This way we still have the same behavior for the arm mechanism. Whenever I move the inverse kinematic, the arm is still following, but instead of being constrained directly by the controller, it's constrained by the child of the stretched bone. If I now select the stretched bone and add a limit scale, we will be able to limit its movement. The only axis that will be interesting for us is the y-axis. Make sure that it's set to local space. And now, since it's limited to 1 in scale, I can't stretch it anymore. And if I increase the minimum scale to almost 1, the arm won't bend anymore. So if we create a custom property that allows us to drive those values, we will be able to control the arm bending through a custom property. You can then test the stretching by increasing the maximum value, for example, and then we will create the custom properties to drive those. So I will go onto the property bone, and we will need to create a custom property for the minimum value and for the maximum value. As those two custom properties are created, I will copy their data path. Then I will get back onto the stretch bone and right-click on it and create a driver on the minimum length and the maximum length. As before, we will use the average value, use a single property, and pass the data path. We need to repeat the process for the minimum value, going onto the property bone and copying the data path of the minimum value custom property and creating the new driver. Then I advise you to play a bit with the minimum and maximum value to get familiar with the behavior of this mechanism. I generally play between 0.90 and 1.05. One thing I'd like to fix here is the behavior of the hand. Since it is supposed to rotate along the forearm axis, but the inverse kinematic controller is not aligned with the forearm, its rotation behavior is not natural. So in edit mode, I will unparent it so that it won't follow any transformation from the inverse kinematic anymore. To be able to control its rotation using the inverse kinematic controller, I will select the bone and then add a copy rotation from the inverse kinematic controller to this bone. We need to set the source and target to local space, and then we can test the rotation on the y-axis by pressing Y twice when using the rotation command. We can click the inverse checkbox on the y-axis to have a proper behavior. Since the hand bone is no longer parented, it doesn't follow the controller, just following its rotation. To fix this, we can add a copy location constraint from whether the MCHIK or the forearm bone onto the hand bone. Here I'm just repeating the sequence. So now the bone is following the location of the wrist. We can control its Y rotation using the inverse kinematic controller, but it doesn't follow the forearm rotation. So what we can do is select the forearm, then select the bone, press Ctrl-Shift-C and add a copy rotation. The copy rotation will override any controller. But if we place this newly created copy rotation first, and then our copy rotation from the inverse kinematic occur, then both will be combined and will work. The only thing we need to do is to get rid of the X and Z axis so that only the Y axis is controlled by the inverse kinematic controller. And so we have fixed the control of our hand. So basically, the forearm is constraining the X and Z rotation of the hand, while our control inverse kinematic bone allow us to control its Y rotation. Again, feel free to rename your constraint for organization's sake. Now our IK chain is almost done. I will just extrude a new bone from the elbow, press Shift N to realign it on the global Z, and unparent it and move it on the Y axis. This is going to be our control pole target for the arm. The pole will allow us to orientate the elbow whenever we are using inverse kinematic. After it's properly named, I will go back into pose mode, select the forearm bone with the inverse kinematic constraint. In the constraint panel, in the pole, I will select our armature and select the bone. You can see that the arm is twisting and we need to control the pole angle and set it to -90 degrees. This value can vary depending on the position of your pole target and the axis you've been using to rotate the arm. You can fine tweak the correction of the pole angle going back and forth into edit mode and tweaking the value. Then I will organize all my bones in different layers by going into the bone layer manager. I will uncheck the hide empty so that I can access all the empty layers, and I will create an MCH layer and then an arm FK, arm IK, and I will move the different controllers in those different layers by selecting the bone and then clicking the round shape on the line. I will move the control FK bone onto the FK arm layer. Then it's time to reposition our chain. I will select the forward kinematic chain in edit mode and offset it on the x-axis by -0.5. select all the inverse kinematic bone and offset them by -1 on the x-axis. Now all of our bones are properly aligned. The last feature I'd like to add is to be able to change the parenting of the inverse kinematic, whether it will be parented to the controller torso or to the root bone of our character, so that the hand will be free of movement or will follow the torso of our character. To do so, we need to create intermediate bone. So I will go back into edit mode, select the control IK bone, and I will duplicate it and scale it up twice. I give each bone a different scale so that we can clearly identify them. You can call this bone MCH parent 1 and MCH parent 2, for example. The last or larger bone will be parented to the root bone. You can access the relation directly in the bone option, going into relation and typing root here. Then I will select the middle bone and parent it to the target torso, pressing Ctrl P, keep offset. Then go back into pose mode, select this intermediate bone, then the larger one, press Ctrl Shift C, and add a copy transform constraint. Finally, we need our controller to be the child of the larger bone, so I will parent it to it. Now, in pose mode, if I rotate the torso, I will see the IK end following, because it is the child of this bone, which has a copy transform from a child of the torso. As soon as I dial down the influence, we can see that it's no longer following the torso. So now we can create a custom property that will allow us to dial on the influence and set whether the arm is following the torso or the root bone. In pose mode, I will select the arm property bone, add a new property, call this IK parent.L. Then I will set the property value to 0 and 0 or 1, it doesn't matter. Then right click and copy the data path. Then we will go back onto the constraint bone, right click on the influence, add a driver, set it to average value, single property, select the armature, and pass the data path and update. And we are done. Using an integers on the driver value allow us to avoid decimals in the value so that it goes from 0 to 1 as a simple switch. From there, you can reorganize the different bone in the different layers. Once you are done, just display all the bone. In edit mode, select all the arm bone and property bone, right click, symmetrize, and then you will need to rename the custom properties on the property bone on the right side and also reset every driver. If needed, you can slow down the video using the YouTube controllers if you need to see every step, but it's all what we have done just before. I'm just recreating the different drivers, because when you symmetrize an armature, it won't symmetrize the driver 2, or it won't retarget the driver. Renaming bones, this kind of stuff can be a bit tricky whenever it comes to driver, because it won't necessarily update the data path, for example. So be very cautious whenever you need to rename bones or whatever you want to rename. If it's holding a driver, you may have trouble. Don't forget to check the different driver you have recreated. Then you can create 2 new layers, naming them FAArm.R and IKArm.R, for example, and moving the controllers accordingly. Let's now start working on the spine rig or torso rig. It will be honestly way more simple than the arm rig. With all the torso bones selected, I will press Shift D and move them into a new layer. I will hide the target layer and display this new layer that I will call torso. With the hips bone selected, I will press Ctrl Alt F to flip the bone. Then I will rename all the bone with the prefix control. So this is going to be the control hips, control torso, and control head. I will display back the target bones and I will parent my target hips to the control hips. Then I will scale down my torso controller just for the sake of readability. Making it smaller will allow us to distinguish it compared to the target bone. And I will parent the target bone to the controller bone. I will also scale down the control head bone, but for the time being, I won't parent the target bone to this control bone. Before we go further, I want to create a main torso controller or center of gravity controller. In edit mode, I will select the joint between the control torso and the control hips and extrude on a y-axis a new bone. I will clear the parenting, or you can parent it directly to the root bone, and we will parent the control hips and the control torso to this new bone. Then I will unhide all the layers for the torso and we will duplicate the head bone, whether it's the target or the controller, doesn't matter, and we will move it on the y-axis. The idea is to create a bone that will serve as a target for the head rotation. So we will call this bone mechanism target bone and we will use it to constrain our TGT head bone. I generally use the dump and track constraint for this kind of mechanism, but since our character only rotates on one axis, we will use a locked track. This will allow the bone to rotate only on one axis when tracking the target. We want to aim with the Z-axis and rotate around the Y-axis. We will obviously need to update the constraint accordingly. So the point 2 will be Z and the lock will be Y. So the lock is the axis around which we are rotating. If we now parent the MCH target bone to the control head, whenever we will rotate the head, the child will follow, and so it will also influence the orientation of our target bone and so the head. Now what I'd like to do is to be able to isolate the target from the head rotation, a bit like we will do for eyes. So what we will do is that we will create a new bone by duplicating the MCH target. As usual, I will make this bone smaller, and this is going to be our control head target lock bone. And we will parent it to the root bone. Then we will use this bone to add a copy constraint on the MCH head target. And now when the copy constraint influence is set to 1, the control head target will control the target. And when the influence is set to 0, the control head will control the head. So as usual, we will create a custom property, this time directly on the control head bone, to drive the influence of the copy transform. This way we will be able to move the character freely while the head is always tracking a point in space, which can be very useful whenever you have a walk cycle, for example, and your character is watching something. You won't have to counter animate it. This is exactly the same mechanism as for an eye tracker, but here we are using it for a head tracker, since the eye of our character don't move and we don't really know where he's looking at. If you want to be able to control the position of the head, meaning that you want to be able to move it up and down, for example, you can parent the target bone to the control head. If you don't want that, just lock all the axes but the Y rotation. Since scaling or rotating the control head lock won't change anything, you can lock those transformation channels. Now that we are starting to rig the legs, there is something very important you need to do, is to align the leg bones. Here the def leg hasn't the same orientation as the def shin. This is something I've forgotten to do before going forward and it was a bit painful. Select all the bone, press Shift N and use global y-axis or global negative y-axis so that all the bone roll are set in the same direction. In this case, the Z is pointing forward. So do this on both legs, and don't worry if I don't have the same bone alignment later on. The leg rig will have a lot of things in common with the arm rig. I will duplicate the chain once and move it on the x-axis by 0.5 and repeat the process to have two chains. I will rename those Control FK for the first chain and MCH IK for the second chain. Then, as we did before with the arm rig to build the switch between forward kinematic and inverse kinematic, I will add a copy transform from the forward kinematic chain onto the target chain, and I will repeat the process with the inverse kinematic bones, adding the copy transform and hiding it so that we are not bothered with the bone getting one on top of each other. So let's now build the inverse kinematic controller. We will extrude a bone from the heel of the foot and we will unconnect it. Then in pose mode, I will add an inverse kinematic constraint from this bone onto the MCH sheen. We can see that the controller goes a bit in every direction because we are applying an inverse kinematic constraint on aligned bone. Both the leg and the shin MCH bone are aligned. To prevent this problem, we will select from the side view with the C key all the bones of the knee and we will slightly offset them forward. With the original armature slightly bent, Blender will have less difficulties to figure out in which direction he has to bend the knee with the inverse kinematic mechanism. As we did before for the arm, we can go in the inverse kinematic option of the shin bone and lock the Y and X axis. If you made the bone pointing forward on the Z axis, then you will need to lock the Y and Z axis. In my case, I haven't rolled the bone as shown previously. So just make a little test so that your knee is bending properly. The foot roll mechanism will be slightly different from a usual mechanism where you have the toes that are articulated too, but the principle is kind of the same. From the ankle, I will extrude a bone onto the corner of the heel of the foot. Press Shift N to recalculate the roll in global Z and Control Alt F to flip the bone direction. Now the ball will be able to rotate around the heel. Let's extrude another one in side view for the tip of the foot and invert it, pressing Ctrl Alt F. I will rename them as mechanism bone and we will create a mechanism that will allow us to rotate whether around the heel or the tip of the foot using only one control. So we need to create another bone for the control. I will extrude it from the heel of the foot and just unparent it and call it control foot roll. This bone will be used to make the two other rotate, but first we need to parent the toe bone to the heel bone. Then we can get back into pose mode. We will select our control foot roll and we will set a first copy rotation on the heel bone. We will set it from local space to local space. Press Ctrl R and switch to XYZ Euler and lock every control channel but the X rotation. Since the Z axis of those two bones are aligned, whenever I will rotate this controller, the foot will follow. Now we want the MCH heel to have a limit rotation so that it will rotate only backward and not forward. So we will limit the X and set it to local space. The Ctrl IK foot roll allows us to rotate the foot on this local X axis and the limit rotation avoid the foot to go through the ground in a way. I think I've forgotten to mention that you need to parent the MCH IK to the MCH IK foot roll. This way it triggers the inverse kinematic whenever both MCH foot roll bones are moving. Since we need to set the same constraint on the toe bone, I will select the toe bone, then the constraint bone, go to pose, constraint, copy constraint to selected bone. Now in the limit x rotation, we will just invert the values, set the minimum to 0 and the maximum to 180 degrees. This way, whenever we are rotating the controller backward on the negative value, it triggers the heel bone, and whenever we are rotating it forward, the other bone is triggered. The thing is that both bones are triggered at the same time, but the limit rotation will avoid us to see any rotation from those bones. And so we feel like there is a switch in the rotation. From there, we can extrude a bone from the knee and unparent it and move it forward on the y-axis. This is going to be our pole target for the leg inverse kinematic mechanism as we did for the arm. We can also extrude backward on the y-axis a bone and unparent it. This is going to be our main foot controller. Let's parent the control IK foot roll to this new master bone, and also the MCH IK heel bone, or nothing will happen whenever we will be moving this controller. Now we need to set up our pole target, so I will parent the control pole to the foot as it makes sense. And then in pose mode, I will select the MCH IK shin, and in the pole target, I will select the armature and set our control pole as being the pole target. Since my bone roll is kinda weird, I will have to input like a 180 degree pole angle, but you should be good to go with a 90 degree pole angle. Just try different value until the knee is properly aligned. This also helps Blender figuring out where to bend the knees, and so it removed the glitch we had before. As for the arm, we can now build the length mechanism. So I will just extrude a bone from the hips, and this is going to be our MCH leg length. We will snap the tip of the bone onto the ankle joint, and then in pose mode, we will add a damped track and stretch to constraint from the MCH IK onto this bone. The MCH IK now also controls the length of this bone. In edit mode, we will duplicate the MCH IK, make it smaller so that we can see it properly. This is going to be our MCH length number 2, and we will make it a child of the length bone. We will also use this newly created bone to replace the one in the MCH inverse kinematic. So go into the inverse kinematic constraint, and in the bone just paste its name. We can now rename properly the different bone if you have any .001 or .002 suffix, and I will move them in the different layers. Then we will realign the different bone, and we will create the custom property that will allow us to deal with the length of the bone by limiting it, and so making the leg able to bend or not in inverse kinematic. When every bone is in the proper layer, I will display them all, go back into edit mode, select both chain, and move them on the left by 0.5 unit, and repeat the process for the last chain, gx minus 0.5. From there, I will extrude vertically a bone from the hip joint that I will unparent, and I will move it on the side. This is going to be our leg property bone. So in pose mode, we can create our custom properties on the property leg. So we just need to create an FK to IK switch and also a minimum length value. Here I will be also created a maximum length value, but it's useless because we can't stretch the leg. So don't create it because I will get rid of it a little later on. As we did before, I will right click on the IK FK value and copy the data path, go into my target leg, and I will search for the copy transform that serve as an IK FK switch. So we can rename it, add a driver, set it to average value, select single properties, select our armature, and paste the data path. You can rename the constraint if you want, copy the driver by right-clicking it, and then go on the different target bone of the leg and paste the driver on each copy transform influence. Whenever you're creating drivers to switch mechanism, just test it right away. Even if you're convinced you didn't did any mistakes, sometimes we forget something or we just don't copy it properly. Then we can go onto our length bone and we will add a limit scale on the y-axis in its local space. As I told you before, we don't need to play with the maximum value but only the minimum value, because the knee bends only when we are shortening the leg length. If we are extending the leg, nothing will happen, and so working on the maximum size doesn't matter. We can slightly raise the control IK foot, switch to inverse kinematic, and right-click on the leg length minimum L and copy the data path. Then, as usual, on the limit scale constraint, we will right-click and add a new driver that we will set to average, single property, source the armature, and paste the data path. So here you can see that the mechanism will be working, but I won't have the right behavior, because as told before, I've forgotten to parent the bone that drive the IK to the length bone. Now the mechanism works properly and I no longer can bend the knee as soon as the minimum length is set to 1. As soon as we will reduce the minimum length, we will be able to bend the knee and have a more common inverse kinematic behavior. The only thing we are missing now is the possibility to lock the rotation of the foot whenever we are using the inverse kinematic. This is something I figured out later on. This is why I already have some custom shape, but don't worry, I will show you how to create them. But for the time being, let's fix this problem. In edit mode, I will display the name and duplicate the MCH-IK foot bone. This is going to be our MCH foot roll lock bone, and it will allow us to choose whether or not we want to be able to rotate the foot when using inverse kinematic. I want it to be a child of the MCH-IK shin L.002. So it will basically behave as a child of the shin mechanism for the inverse kinematic leg, and so whenever we will be moving the leg, it will just follow the rotation of the shin. So we can use it to add a copy rotation constraint onto the MCH-IK foot, and then create a custom property on our property leg bone, so the one with the bold shape here, but in your case it won't have any custom shape yet, and you can call it rockFootRoll.L, for example. As usual, once created, we will copy the data path, create a driver on the copy rotation constraint, set it to average, source the armature, single property, and paste the data path. When activated and using inverse kinematic on the leg, the foot won't rotate anymore and we will have a more Lego-like behavior of the leg. So don't worry if you only have the left leg done, we will symmetrize the rig right now. In edit mode, we will select all the bone on the left side and delete them, so make sure that you don't have any hidden bone. Then select all the bone on the left, right click and symmetrize. Then you will just have to remap the different driver from the left to the right. So on the custom property bone on the right, make sure you copy the data path, make sure you rename the driver, it's not mandatory but it does make sense, and make sure you also create the driver for the lock rot of the foot on the inverse kinematic chain we've just created previously. I'm speeding up the video because this is something we have done a lot of time before. We will now go into the armature option in the bone group. The idea is to set a color for the different bones that will help us to identify them on the rig. In the armature option, you can create a new bone group, choose a color set, then select the bones you want to assign and click the assign button. Now in pose mode, you can see that the color of the bone has changed. We can reproduce the process for any group we want to create. I generally separate the arms for each side and the legs for each side. And the more complex the rig is, the more group I will create. Don't overcomplicate your group creation because you will barely go into the groups to select the bones. I will go back into object mode and create a new circle. This will be our first custom shape, allowing us to give a specific shape to the different bones on the character and making them easier to identify. I will select these 4 vertices and I will scale them out in an arrow shape. I will call this WGT root for widget root. Then go back into pose mode onto the armature, select the root, select the bone option, go in the viewport display, and in custom shape source my widget. Then I can change the viewport scale. I won't be showing all the custom shape creation, but instead I will show you how custom shape behave. So I will add a cone in the Dune document with different bones. I am displaying their axis and I will also display the axis of the cone I've created. The main thing you need to know is that Blender will use the local axis of the widget object and align them with the local axis of the bone. So if I source my cone as a custom shape of this bone, you can see that it's rotated. And this is because the cone is pointing in the Z direction in its local space. So it will point in the Z direction of the local space of the bone. If now in edit mode, I rotate the cone so that it's pointing toward its Y local space, we can see that our bone seems to be aligned with the cone shape. Another thing to mention is that the head of the bone will be aligned with the origin of the object. So if I offset the object in edit mode, it will be offset on the bone shape. So a commonly used technique to create your custom shape is to move the object in object mode and align it with the bone, scale it if needed, all in object mode. And once it's matching the position of the bone, enter edit mode and modify it. You will see the bone custom shape updating as soon as you will be editing the object shape. Again, local space and role of the bone is pretty important even for this. So whenever you are creating a custom shape, if you can't figure out in which direction you have to turn it, I advise you to display the axis of the custom shape so that it will help you. If I add a Suzanne and switch the custom shape of this bone to be a Suzanne, you can see that it's gonna be pretty hard for me to know in which direction I have to turn the Suzanne so that it does align with the original shape of the bone. And this is because the bone has a custom role, so its x-axis is not pointing in the same direction as the x-axis of Suzanne, and so it's a bit confusing. So to make my life easier in object mode, I will align this Suzanne object with the Suzanne shape on the bone, and from there I will be able to edit it freely. So keep your custom shape as simple as possible on your Lego rig, but if you want more complex shape, this technique may help you. Let's now work on the facial expression of the character. The little thing you need to know here is that you can create multiple UV islands for a same character or a same object. So you can see here a pretty classic UV map, but on the right in the UV map stack, we can see that there are multiples UVs. And we can use those different UVs in the shader editor, for example, to source the different shape of the character. On the main material, we can see that we are using the eyes custom UVs to put on top of the main character the eyes layout. So if I go in edit mode, select for example the mouth custom UVs, and then I make the mouth island sliding, you can see the texture sliding on the face of the character. Unfortunately, there is a modifier that allows us to modify the position on the UVs based on an object, like a bone, for example. The two planes on the side of our character will just serve as a reference in space. You can see that they have been subdivided so that a vertex is set in the center of each eyes shape or mouth shape. And those planes are square like the texture is. So we will be able to use those vertices as a reference point to create a new custom bone. So in edit mode, we will select the top left corner vertices and snap the cursor to it and go back onto our armature in edit mode and add a new bone. We can move this bone on a new bone layer that we will call face, for example, and we will call this bone the mouth ref bone as mouth reference. Then we can duplicate the bone and scale it down as we usually do. And you can call this bone control face bone, for example. The first bone will be the origin of the UVs, while the second bone will be the offset of the UVs. From there, let's get back into object mode, select our character, add a modifier UV warp. We want to be modifying the UV map of the mouth, so I will select UV mouth. In the from and to option, we need to reference our bones. So I will search for the armature, then select the ref mouth or the control mouth, and in the target slot, we will select the other bone. We might need to reverse their position later on, but it's always a bit of trial and error whenever you are working on those. From there, you can see that whenever I'm moving the control face bone, we see the mouth shape sliding on our character. Using the snapping tool can help to make the bone snapping onto the vertex reference. We need to repeat the process for the eyes shape, so I will go into edit mode, select the vertex, snap the 3D cursor, then I will add a new bone and I will duplicate it, scale it down to create the reference and the controller. Then we can go back in object mode onto our character, go to the modifier stack, add a new UV warp modifier. This time we will source the eyes UVs and we will source these two new created bones. So you may have figured that the shape on the face of the character were not following the reference, and this is because we have to invert the reference in the modifier. So in the from option, you will use whether the control eyes or the control mouth, and in the to option, we will use the mouth ref or the eyes ref. So make sure you modify it into your modifier. And now whenever I'm moving the controller, you can see that it matches what I have on the reference. Now what I like is create a mechanism that will allow us to choose a number to select the kind of shape we want. To do so, we will be using an action modifier. So I will lock all the transform channel we won't be using. We will only be using the location channel. And I will open the action editor. So go to the dope sheet and switch to action editor. We will create a new action and call it face selector. I will select the two controller bone, then we will go into the scene properties and we will set the start and end frame from 0 to 20. This is because we have 20 mouth shape and each frame will allow us to select one of them. With the snapping tool enabled, let's move both controllers on their initial shape. Select both of them and with our timeline set to 0, press I and location, or you can click I directly onto the location in the item menu. We will create a new window and use the timeline, and in the keying we will set location. Then in the 3D view I will press GX and snap onto the vertex for both bones. So first move on frame 1, offset, and once you've offset the bone, press I. It will automatically set location keyframe since we have set it in the keying. So now that we know that it's working, we can set auto keying and move on the X-axis on each frame. So I use the arrows of the keyboard to switch frame, and for each new frame, frame 5, 6, 7, etc., I switch the bone position onto a new shape. So it's basically recording a new keyframe for each bone position and each shape of the face. When you are done, uncheck the auto recording, and whenever you will scroll through the animation, you will see the different shape of the face appearing on your character. Then we can go back into edit mode on our armature and unhide the bone. I have duplicated one of the bone off screen. You can see it called MCH mouth. I will duplicate it and move it onto the other side. Then we will go back into pose mode and we will use each of those newly created bones to constrain the previous one using an action constraint. So I will first select the MCH, then the controller, Ctrl-Shift-C, and create an action constraint. The action constraint will allow us to play the previous animation on the target bone by moving another bone, for example. Since we have 10 different shapes of eyes, I will set the start frame to 0 and the end frame to 10. I will select the action we have created and tell Blender to use the Y location on the local space of my MCH bone. I will set its range from 0 to 1. Now when I move the controller on its Y axis from 0 to 1, it does play the whole animation. If I force it to move by 0.1, it will automatically snap on each eyes shape because we have 10 different eyes shape that are being brought on a 0 to 1 movement. I did exactly the same thing on the other side, setting an action constraint from 0 to frame 15. Since we have 16 different face shape, 0 is the number 1 and 15 is the 16th shape. And to make my life easier and keep the 0.1 step, I've set the range from 0 to 1.5. Now, as told before, instead of moving the bone by hand, we will be using a custom property. So one for the eyes, one for the mouth shape that we will be storing on the head bone. You can call them mouth shape and eyes shape, for example. And the important thing here is to set the properties value, base value, with integers so that we don't have those decimals in the range. As for the minimum and maximum value, I will set 0 to 10 for the eyes and 0 to 16 for the mouth shape, since we have 10 and 16 shapes accordingly. Then, as for all the drivers we've set before, I will right-click on the value and copy the data path. Then I will go onto our bone that is driving the animation constraint, lock everything but the y-axis, add a new driver, set it to average value, single property, source the armature, and copy the data path as usual. But since our animation constraint is set with steps of 0.1 to 0.1, we need to switch back to script expression and multiply our variable by 0.1. So I will just write var multiplied by 0.1. So now if I change the value from the custom property, we can see our MCH mouth bone moving up by 0.1 unit. It triggers the action constraint and we can see the mouth shape changing, which is a mistake. So I will copy the driver of the mouth shape and paste it on the MCH eyes because I've been using the custom property for the eyes. And now I will go back onto my property bone or head bone here and copy the data path for the mouth shape and edit the driver and replace the data path of the eyes by the mouth. So if you now test your rig, it should be fine. Whenever you will move the eye shapes, the eye will change and the mouth shape will do so. From there, we just need to move all those bones onto the MCH layer for organization's sake, and we will customize a bit the rig layers to display them properly. To create a custom UI using the Bone Layer Manager is super simple. Where there is a sign rig UI, you just have to set a number. If you assign the same number for two different rig layers, they will appear on the same line. So it's pretty straightforward. What I advise you is to set, for example, the arm left and arm right on the same line so that it feels more natural. Don't forget to create layers for IK and FK leg.r for the right side and assign them to the number you want, and you're done. Your rig is done and you can start animating it. I hope you've enjoyed this long tutorial and I will see you in the next one.